Uh, Hi everyone. So since it is already time, I'll be starting now. Uh, by the way, excuse me. Sorry for missing the class, missing the session on the last Tuesday on 13th. I was actually my computer was not working properly, so that is why I had to cancel it. This Today is the session. Today is a makeup session for the session that we missed on Tuesday. It is on 13th August. Okay. All right, so without any further ado, let me start by sharing the screen. Let's check whether the recording is on. Yeah, recording is on. Fine. I think everything is working fine. Hmm. All right. Okay. Hmm. All right. So share the screen. I hope my screen is visible to everyone, and I am also audible to you. Anyone can unmute and say whether I'm audible or not, and my screen is visible or not. Okay. Okay. Fine.
Yes,
Ah.
Mayank, it's visible.
Yes. Thank you. Thank you very much for the confirmation. Okay, fine. Yeah, so before starting, let us again, like all times, let us first introduce. So, again, this course is Analog VLSI Design. The course name is Analog VLSI Design. It's an NPTEL course, NPTEL Massive Open Online Course or MOOC course. Fine. The instructor for this course is Dr. Iman Mundal. He's an assistant professor in the Department of Electrical Engineering at IIT Kanpur. Myself, I hold these discussion sessions. My name is Mayank Anupam. I am a PhD student at in the electrical engineering department at IIT Kanpur. Okay. Yeah. So today we will be holding the discussion for the content that was covered in week 3 of the course. Okay. So the summary for I mean, overall summary, overall topics were what? So we learnt about how to find out incremental gain in a non-linear two-port network, right? So in week 2 we were introduced to the concept of a two-port network. We learnt about small signal parameters, or sorry, the Y parameters, right? Y11, Y12, Y22, Y21, something like that, correct? And this week what did we do? We learnt about how to find out incremental gain, how to make the network such that it can provide some incremental gain. That is what we saw in week 3. Also, from there on, I mean, first we discussed how can we get incremental gain. We discussed and then we discussed what are the constraints that come on the Y parameters, right? To achieve some incremental gain in the network. So basically, that was what was introduced in desirable IV characteristics. So we learned about what should be the Y1, Y11, Y12, all those things, right? The constraints on those things. Fine. After that, we moved on to the basically from the block levels diagram to the circuit level. I mean, we have a device which can provide all those things. So that device is a MOSFET. So MOSFET also acts as an amplifying device. So how can we use it for amplification? That is what we will see next. Okay. We quickly discussed about the characteristics of MOSFET, how MOSFET works overall. I mean, from a very top level view. We'll not go into details of the device level physics of this, but we'll just see what I mean, just to understand, just to have a basic understanding how a MOSFET works. That is how we saw. We also saw what are the IV characteristics of a MOSFET. What is the current to voltage, this thing equation? What is the equation, right? Which governs the current to voltage relationship. Fine. So before moving on, so I want to ask: is there any doubt in this particular thing? So I know I'm late slightly, but still, if something you didn't understand, you can just ask me now. If you have any doubt, any difficulty in understanding or following the concepts that were covered, you can ask me now. So if you have no doubt, then I will just move on. Okay, fine. I'll just move on then. That condition. Nikhil, you were asking something about some question.
Yes, I was asking about the key actually.
Yes. Tell me what question in this?
Week 3, fifth question actually.
Week 3, fifth question. Okay. Let's see week 3, fifth question. Okay. What is the problem here?
I will check once which question. Week 3, that is fifth question, yes.
Yeah. What is the problem here?
Like the answer which I have got is 5.08 actually.
Okay. Let's check. Solution is also given, right? I think I have not gone through the solution. Let's see what it is. Question
They have
number.
been saying like like the values are taken some differently in the discussion forum. They have said like
Okay, let us solve this question. Okay, I have a question which is just like this, so we'll solve this today. Okay, a question just like this.
yes, yes.
Anyway, but before that, any other thing?
Here like week 3 is fine, and coming to week 1, one more question is there actually. Week 1, week 1 is 1 minute.
Yeah, week one. I have on display.
Seventh question.
Seventh question.
That is minus zero point 0.5. Like in key, it is given as minus zero point 0.5 only, but here in like in the solution, right, it is given as minus zero point 0.5. But here, like they have typed it minus 1 actually.
Seventh question -1 -0.5. Okay, there is a two
In the
decimal
solution,
places.
right, it was minus zero point 0.5, but here they have given minus
So
1.
I hope, I think, so was there no grace marks allotted for this particular mistake?
No, no, no.
Okay.
Like I have written minus zero point 0.5, but in the
So
solution also it see.
you have posted this on discussion forum, have you?
Yes, yes.
Week
See, like
3,
assignment 1 weeks question number 7.
where is that?
That one, like it's above only, Mayank.
Okay.
There, wait.
Yeah, this
Nikhil
one.
Yadav. Nikhil Yadav, down. In the middle.
This is week 3, question number 5.
Here, week 1, question number 7. In the
Oh,
middle is
this
there.
one.
Yes.
Middle, where? Oh, yeah, this. No, not this. This one. Yeah,
Yes.
I see this one. This one, right?
Yes, yes.
Okay, okay. Okay, don't worry about it. I will look at it. Okay,
Yes, sure.
I'll take a look at it. Fine. Nothing else, right?
Nothing.
Okay. Fine. Anyway, so today let's solve one question. So again, I have only one question. I hope this will be able to cover everything. The same question basically. Question number 3. I mean assignment 3. What you have? The same question I have here, with a slight twist here and there. The first part is exactly the same as the first question of assignment 3. So let's solve it together. It will be much better if you solve it with me. Hmm. Fine. So what do we have here? We have a network here. All right. This is a network here, and uh, we have defined the node, or the three nodes of this network, which are coming out as gate, or G, D, and S. Right? We have defined it like this. We have named it in this manner, G, D, and S. Okay, and after that, and after that, now we have also said that we have also given a relationship between the currents. So the currents are also defined in this manner. See, the currents that are given here, the current I1 is going into this network, right? Like this. I2 is also moving into this network like this. So now we have defined the relationship between I1, I2 and all the voltages. So I1 is always 0. That is given. So no need to worry about this. But I2 is not 0. What is I2? I2 is beta times this particular thing. I mean, whatever the relationship is. So it depends upon. So what I2 depends upon how many voltages? It depends upon the voltage. So I2 is a function of, let's write it like this. So if you have a voltage, this is VGS, VDS. Huh? So I1. So I2 is a function of both VGS and VDS, right? That much is understood from the equation itself. Moreover, you are also given that if VGQ is equal to, which means that the quiescent point or the operating point voltage of voltage at this node. Oh, sorry. If the operating point voltage at this node VGQ is 3 volt, VDQ is 4 volt, and VSQ is 0 volt, then find out all the Y parameters of the network. So let us do that. Before doing that, yeah. Before doing that, let's find out what are the operating point voltages VGSQ. So what will be VGSQ? It will be VGQ minus VSQ. So since you have already solved it, it is 3 volt. Then again similarly VDSQ will be VDQ minus VSQ. So that will be how much? 4 volts. Alright, understood? Beta is already given here. BTH is also given here, and lambda is also given here. Okay, so tell me, how do you find out the Y parameters of this network? So what is the relationship? How do we define Y parameters? So it is I1 is equal to Y11 times V1 plus Y12 times V2. Am I right? So you will have to help me. Okay, you will have to say something. Those who are attending, because this this assignment is already over. I just wanted to discuss it here. So those who are present, please help me out here. So is it right whatever I have written here? Okay,
Yes,
so
correct.
yes, what is I2? You can speak up whenever you want to. You unmute yourself and speak up, please. What is I2?
I21 V1 plus Y22.
Correct. So this is fine. These are the relationship which we know, correct? So tell me, how do we find out Y11? How do we find out Y11? We know that
Dou
Y1,
I1 by dou V1.
yeah, it is I1 upon V1 when V2 equal to 0, right? Am I correct?
Yes.
Yes. Also, so this here is a general definition of Y parameters. We are interested in small signal Y parameters, right? So it should be clearly mentioned here. So the small signal Y parameters. Yeah. So if you have small signal Y parameters, then this equation can be written as y11, or rather y11 times v1 plus y12 times v2. I2 is equal to y21 times v1 plus y22 times v2. Correct? So this, in that case, this becomes y11 is equal to I1 times v1. So when I say this is small I1, what does it mean? Small I1, what does it mean? All these small this thing, small variables, v1, v2, I1, I2, what do they signify?
Incremental voltage.
Yes, they are incremental voltage, correct. So all these quantities here, these are all small, sorry, incremental uh, signals. Okay, so basically I1 is equal to delta I1. Okay, I2 equal to delta I2, V1 equal to delta V1, and small v2 equal to delta large v2. Okay, so this is how it is. So y1 is equal to I1 by v1 when v2 is equal to 0. So tell me, how do you do it? What is y11 in that case from this equation, right? What will be y11?
0.
Yes, because I1 is always 0, so it doesn't matter, right? Okay, fine. What is y12? It is I1 upon v2 when v1 is 0. So what will this be? Again 0, right? Because I1 is 0. Fine. Now comes y21. It's equal to I2 by v1 when v2 equal to 0. So what will this be? How will you find out? So since please note that this is delta. Okay, these quantities I1 small, I1 small, these are all delta. So it can be written as delta of I2 upon delta of v1 when v2 equal to 0, when delta of v2 equal to 0, right? Or in other way, you have to just differentiate I2 with respect to what? V1, right? You have to just differentiate I2 with respect to V1. So this is delta I1, I2 with respect to V1. That's all. Keeping del V2 is equal to 0. Fine. So what will this be? It will become what?
2 beta VGS minus VTH.
Yeah. So by the way, this V1 here, V1 is what? I forgot to mention. So V1 is
VGS.
VGS, V2 is VDS. Okay. All right. This becomes 2 times beta VGS minus VTH into 1 plus lambda VDS, right? Am I correct? Hmm.
Yes.
Am I correct? Yes. So can someone tell me why didn't I put VDS is equal to 0? I just said that V2 equal to 0. Something that like that I said. Why didn't I put VDS equal to 0?
That is change in VDS is 0, but VDS has some value.
Yeah, exactly. Correct. Very good. You see, VDS cannot be changed. Delta VDS is 0. Delta V2 is 0. It doesn't mean that VDS itself is 0. VDS can be something, it will be operating point voltage. So here you have to mention VDSQ. Okay, understood? And similarly, when you write VGS, it is also VGSQ. Got it? When you differentiate it, when you have differentiated it, at that time, this quantity after differentiation becomes VGSQ, right? Am I getting through? Is the point getting through to you? All right. So in that condition, what does this become? 2 times. So whatever it is, I mean, let's ignore the calculation. This is what it is. This is what is Y21. Okay. Now what is Y22? It is I2 upon V2 when V1 is equal to 0. Same thing, right? So this is again delta I2 upon, or rather, let me just write it directly. It is differentiate I2 with respect to V2 when your V1 remains a constant. So what does this become? Beta times VGS minus VTH the whole square, correct, into lambda times VDS, right? Or sorry, lambda only lambda, right? Am I correct? Am I correct?
Yes.
Yes. So this then becomes what? I'm just writing it more clearly. Lambda times beta times VGS minus VTH the whole square, correct? So this is your Y22, correct? Now if we put the values which are also given in the question, so we have beta equal to how much? 0.5 milliampere per volt square. We have VTH is equal to 1 volt. We have lambda equal to 0.1, 0.01 per volt, and then we have VGSQ is equal to 3 volts, and VDSQ is equal to 4 volts. We have these two things, correct? So if we put all these values, what do we get? Y11 equal to 0 equal to Y12, Y22 becomes 2 times beta times VGS, fuck, VGSQ minus VTH into 1 plus lambda VDSQ. So this is equal to 2 times 0.5 milli into VGSQ minus VTH is 3 minus 1 is 2 volts into 1 plus 0.01 into 4, correct? So how much this will be? So this is Y21. Hmm.
It is
1.
2.08.
How much is this?
2.08.
2 point?
08.
Sure. Is it 2.08? 2 into 1 plus 0.04. So it is 1 plus, yeah, 2.08, correct. Millisiemens, correct? So this is millisiemen. Millisiemen means this is, you understand what is the, what is this S stands for? S is the unit of transconductance. I also said one day about in the last, I think last to last class, I think I said something about this. That this is a unit of transconductance. 1 second. Am I audible now? Am I audible?
Yes, 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 yes.
Yeah,
You are
I
audible.
mean, my earphone got disconnected abruptly. Anyway, I was saying that the transconductance, uh, that this S is the unit of transconductance. It is the S stands for Siemens. Okay, S stands for Siemens. So 2.008 millisiemens. That is the value of Y21. Fine. What is Y22? Y22 is lambda times beta times VGS minus VTH square. How much is this? Lambda is 0.01 times beta is 0.5 milli times VGS minus VTH is how much? VGS is 3 volt and VTH is 1, so 2 square. So this becomes 5 into 10 to the power minus 3 into 4, 22 into 10 to the power minus 2, right? Uh, Again Siemens. So which is how much? 20 millisiemens. Correct? Is this right? Yeah, it is 0.02. Fine. So we have found out all the Y parameters of this network. Okay. So is there any problem till now? I hope there is no problem till now. All right. Moving on. Now tell
Sir,
me. Yeah.
sir, in the previous thing we have to consider the uh, previous calculation. Now
Which
only you did not calculation for that one. Sir.
which part are you talking about?
Recent one which you solved last calculation. As
Yes.
5 into 0.5 into 10 power minus 3.
What is the problem here?
4 into zero point 0.5 becomes 2, sir.
Yeah.
Point,
So
it is 0.02, I think, sir.
yeah. So that is what I've written. 0.02. 20 milli is what?
No,
0.02.
0.02 millisiemens, I think, sir.
No, 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 no. It is not 0.02 millis. Oh, oh, yeah, yeah. Sorry, sorry. I think I made a mistake. Yes.
Will be
Hmm.
micro.
Yeah, yeah, yeah. Yeah, you are right. You are right. So it is 5 into 10 to the power 5 into 10 to the power minus 6, right? Into 4. So it is 20 microsiemens. 0.02 millisiemens. Yeah, you are right. That was a mistake. Yes.
Sir, I have some uh, doubt regarding what our instructor, Professor sir had told in our lectures.
Hmm.
Here we have defined y small incremental y11 is as dou f1 by dou v1
Yes.
in the lectures.
Yes.
We say that I is a function of
Hmm.
v1 and v2.
Yes.
Uh, but we are not. It is dou f1, so it should be dou I1 by dou v1. I think, sir. Is it
Yeah, yeah. So that is what I mentioned.
dou
Yeah.
I1 by dou v1?
Y11 is I1 by V1, right? A small I1 by small V1, which means, and what is small I1, small V1? Here I have mentioned it. I mentioned it here, right?
Yeah, yes, you are. I am able to understand what you have mentioned, sir.
Uh-huh.
But in that lectures, it has given as dou y11 is equal to dou f1 by dou v1.
Okay.
Shall it be changed to dou I1 by dou v1?
No, no,
That
no,
is
no. It's actually no, no. I1 is what? I mean, see, Y1 is Y11 is actually what? It is dou F1 by dou V1. You're correct. Plus dou. Yeah, it is dou F1 by dou V1. This is Y11. Correct.
yes, yes,
Am I right?
yes, yes, yes,
So what is meant there is that if what is meant by f of v1, what is f of v1, what is this f of v1 v2, it is basically I1 only, right?
yes, yes, sir.
Correct. So if you find out dou of f of v1 comma v2, divided by dou V1. When you say dou V2 is 0, what does this mean? Basically dou I by dou V1 when dou V2 is 0.
Oh,
It's
okay,
the
okay,
same thing,
okay,
right?
okay.
I mean, you just F stands for F means what? F of V1 V2 means what? It is basically a function. What is the function? So I1 is a function when you say something like this. So I1 is a function of V1 and V2. That is what is meant here.
Oh,
F
okay.
means it's just a notation to say that it's a function of V1 V2. So what is a function of V1 V2? It's basically the current I1. I1 is a function of V1 and V2. You could have also written like this I1 V1 V2. So it
Ah,
means that I1 is a function of V1 and V2. The same thing.
if it is written like this, I1 is function of V1, V2, it will be more clear, I think. It's
It's
okay.
fine. I
I
mean,
have,
that's a generalized thing, so it's not a problem.
okay, okay, sir.
Oh, yeah.
Okay, sir. Got your point.
Fine. Yeah. Good. So, hmm. Yeah. So now that we have found out all the y parameters of this network, let us try to solve a slightly complicated version of this network. Okay. So I have this question here. The same VGQ I have applied, whatever VGQ we found out, the last question, we had some VGQ given, right? What was VGQ? It was 3 volts, right? So same VGQ I have applied here at the input. So let's RS is equal to 1. Yes. So this VGQ I applied here, but on top of this VGQ, I have also applied a small signal sinusoidal voltage here. Small sinusoidal, not 1, it is actually 1 milli. 1 milli of sine omega naught t. So this is also something which I have applied here. Now at the output, at the other side of this network, earlier I had nothing, right? But now I have applied this resistor R1 and RL, and also this VDD voltage, some VDD voltage. I don't know how much is that right now. So first of all, tell me that in order to honor the operating points that you have already found out. So it was given that VDSQ was 4 volts, right? So tell me, if VOQ, this guy here, is supposed to be 4 volts, what should be the value of this VDD? How do we find it out?
8 volts.
Come again?
8 volts.
How do you do that? How did you find out? So we already know what is I2, right? We already know from the previous question what is I2. What is I2? So I2 is equal to beta times VGS Q minus VTH is I2Q, right? Is I2Q. Or is it's very bothersome to write Q all the time. So I'll just, please understand that if I use all the capital letters, it means that I'm talking about the quiescent point. Okay, so I2 is equal to beta times VGS minus VTH the whole square into 1 plus lambda times VDS. Okay, so what was that? Beta was 0.5. Milli. VGS minus VTH was how much? 2. So 2 square 1 plus lambda was 0.01 into VDS was how much? 4 volts. So what is this? 0.5 milli into 4 into 1.04, right? So how much will this be? 2 milli, right? 2 into 2.08 milli amperes. Correct? Correct? It is 2.08 milliamperes. I2 current. Now, if the current I2 is 2.08 milliamperes, now you have to apply KCL, okay? So at this node, KCL at this node, so let us highlight it. So if you apply KCL at this node, if you apply KCL at VOQ, KCL at VO, what will you get? So VDD minus VO, VDD minus VO divided by 10 kilo ohms, plus whatever, what else, right? So it is plus all the currents that are entering this node should collectively sum up to 0, right? So the other current that is entering this node is what? This one, right? Like this. Or rather, try to understand it this way. Current that is entering this node should add up to current that are leaving this node, right? Anyway, so this is should be equal to the currents that are leaving this node. So current that is leaving this node is I2 plus this guy, right? This guy. So that is VO divided by RL, or RL is equal to 10 kilo. So how much is this? VDD minus VO we already know, right? VO is 4 volts. 4 volt divided by 10k should be equal to I2 we know it's 2.08 milli, plus VO again is 4 divided by 10k. So let's take the terms is equal to 2.08 milli plus 4 upon 10k. 4 upon 10k becomes how much? 8 upon 10k. Fine. So this gives how much? VDD is equal to 2.08 milli into 10k will be 20, right? 20.8 plus 8, right? How much is this? 28.8 volts, right? Am I right?
Mayank, here I have doubt like
Hmm.
that I2 is not the same current which is flowing into RL. Like,
Yeah, I have not. That is what. That is why I have used KCL here. I2 is a current which is flowing into this network, right? There are other currents also. VDD is pushing some current that so part of that current flows as I2 and part of that current flows into RL.
I mean,
Correct?
like I2 isn't it the same current which is flowing into the RL also?
No, how can it be? If I2 is if all the current that is flowing as I2 here, if all of that is flowing through RL, which means that your VDD, this guy is not supplying any current, right? But that is simply not possible, right? Because if there is a voltage difference between if there is some voltage VDD here and there is some voltage VO here, and if these two are not same and there is a resistor connected in between, which means that there will be some current, right?
So if R1 is disconnected, then that case will be right.
Yes, then that case will be true. Yes, got it.
Yes, yes.
Yeah. So 28.8 volt. This is what you got. This is what we got. 28.8 volts should be the VDD. Correct? Is that okay? I hope that is okay.
Yes, yes, sir.
Hmm. Fine. Now, now what? I think it's fine. Yes. All right. So this is fine. Now tell me. Now that you know what is, we have also calculated what is VDD and everything. Now, when I want to look at the small signal parameters, now I want to find out what is the small signal gain. VO, small. This is small signal, right? This is small signal or incremental voltage. VO upon VI. So I have applied an incremental voltage also here, which is 1 millivolt times sine omega naught t, something like that. If I've given like the if I've given that voltage here, what is the incremental voltage that will appear at the output? So we have output VOQ, right? It will there will also be a small voltage VO. What is that? How do you find it out? So we already have done half the job, right? We have already found out what are the y parameters of this network. So we know that y11 is 0, right? And y12 is also 0. So this network can be effectively written as small signal or incremental. In the incremental picture, tell me what should happen to this voltage VDD here in the incremental picture, VDD and this voltage VGQ here. What should happen to these two voltages in the incremental picture?
0.
Correct. They should be 0 because incremental means that there is some change, right? We are trying to see what happens in the if there is a delta change in different uh, excitations of this network. But you know that VGQ is a fixed voltage. Again, VDT is a fixed voltage. So if we have any change somewhere in this voltage, if we have a change somewhere else, that is not going to affect the voltage here, right? These are fixed voltages, fixed voltage sources, independent. So no change here. So that is why this will be simply shorted. Okay, no change means shorted. Voltage will be shorted. Fine. So this is RS, and here we have uh, VI. Fine. Now we also know that what is Y11? What is Y11? What did we how
0.
much? It was 0, right? So what will this resistance be? 1 over Y11, right? Or that should be infinity, correct? Again, what was Y12? Also 0, right? Huh. Moving on, tell me what was Y21? It was non-zero, right? So we'll keep it here. This was Y2, sorry, this was 1 over Y22. Okay. So after this, at the output, what we have connected? That is so this is basically the common ground. Okay, assume that this is a common ground for everything. So if VDD, we are saying that this node, this terminal here, which was connected to a voltage source, so it was like this basically. Uh, this was VDD. Okay. So if this VDD is shorted, which means what? It will be 0, right? It will be again shorted to ground. So we have two resistors here at the output, VOQ, RL and R1. Both are connected from, see, this RL, it's connected between what? This node VOQ here and ground, right? Similarly, R1 is connected between node VO and VDD, but VDD is going to be grounded, correct? This node VDD is going to be grounded in the incremental sense. So R1 is also going to be connected to ground. Got it? So we have two different resistors here. Sorry. So this is R1 and this is RL. Both are connected between VOQ and ground. So this guy here, this is VO, small signal VO. This is VI, and You can also name it as VD if you want to. VDS. This is S. This is VD. So this is basically drain. This is source. This is gate. GDS. So this node voltage here is small VD or VO, whatever you want to say. This is what this you can say as this. This is VG, small VG. Fine. So if you simplify it, so this is basically, since this is infinity, this is zero, so we'll just ignore these two. These are anyway not going to be in the picture. So we'll just simplify and then simplify our picture for better understanding. So VI RS, fine. Hmm. This is how much? This is VGS. Y21 times VGS. This is 1 over Y22. This is RL, and this is hmm, this is R1. Fine. So this is VO. Now tell me uh, what will be the VO over VI incremental gain? What will it be? Yes. Tell me what will be VI? VO over VI. You already solved this, right? Already saw this in the session in the week 3 content that was discussed. What will it be? Anyone? What will be V over VI? What will be VO over VI?
Minus Y21 RL.
Minus
Y21 RL.
Y21 times RL parallel RS, sorry, R1 parallel 1 over Y22, right? Am I correct? Am I correct? So this is same as what was already explained in the lectures also. No, there's no much trouble here. So basically, because of this VGS, there is a current that is going to flow like this, right? A current is going to flow in this manner, in this direction, correct? This is not a good color. It's a different color. So yeah, because of this VGS, current is going to be pulled out of the combination of these three resistors, right? So this is same as saying that there is a current source like this and you have a resistor like this. So what is voltage here? V out. If the current is I, then voltage V out is what? Minus I times R, right? That will be the voltage V naught, correct? So here I is equal to what? Minus, so it is I Y21 times VGS, and what is R? R is a series combination of RL parallel, sorry, parallel combination of RL, R1 and Y21, Y22. That is what it is. So this is VO. So what is VO over VI? So we already know that we already know that VO over VGS is equal to minus Y21 times R1 parallel RL parallel 1 over Y22, and VGS and VI. What is the relationship between VGS and VI? They are the same, correct? Since there is no current flowing in this branch, VGS and VI both have to be same, isn't it? So this is the same as V over Vi. So this is what I have written here. Is this understood? So let's quickly find out what is the again numerical value. So what will it be? Y21, how much did we find? Y21. So Y21 was equal to 2.08, right? 2.08 millisiemens. This is here. And Y22 was 0.08 millisiemens. So Y21 is 2.08 milli into RL is 10 kilo ohms, parallel R1 is 10 kilo ohms, parallel 1 over 0.02 kilo ohms. How much will this be? These three in parallel, how much will this become? So you know that resistors in parallel, uh, it is difficult to find out what is the effective resistance. I mean, just like that. A better way to do it, if you find out that there are resistors in parallel, convert them into conductances, okay? Then you can simply add them. Resistors in series, you know that what is the effective equivalent resistance, we just add them, okay? But in parallel, we cannot add resistors, we have to add them inversely. So in that case, just find out what is the inverse of these and find out what is the effective conductance. So total in that case will become 1 over 10k. R equivalent will become 1 over 10k. 1 over R equivalent becomes 1 over 10k plus 1 over 10k plus 0.02 milli. 0.1 milli plus 0.1 milli plus 0.02 milli. How much will this be? 0.2, 0.22 millisiemens. So what is the net? So R equivalent.
4.54.
Okay, is this 4.54?
Four point five four kilo.
Yeah, you were saying something. What is it 0. 4.54, 0.22 inverse? Yeah, it is. So R equivalent 4.54 kilo ohms, right?
Yes, yes.
Yeah. So then what is the value V over Vi? Minus of 2.08 milli into 4.54 kilo, right? So what will that be? 9.45. Got it? Minus 9.45. So if I give an input of how much? 1 milli sine omega naught t, how much should I expect here? VO. So now Vi was how much? 1 milli sine of omega naught t. So what should be VO? Minus 9.45 millivolts sine of omega naught t. Got it? Is this understood? So this is small signal VO. This so overall voltage. If you want to, if someone asks you what is the overall voltage, total voltage at this node, at the output here, what will you say? At the output, what is the total voltage?
add VOQ plus this.
Yes, correct. So it will be, so total voltage V output is how much? So V and small o. So this will be VOQ plus VO, which will be 4 volts plus minus 9.45 millivolts sine of omega naught t. So this will be 4. Yeah, so this is what it will be. Okay, this is what it will be. So is there any doubt in this question? That one I just solved. So Nikhil, you had some issues regarding this question, right? A question similar to this. I think,
Yes, yes.
yeah. So I hope everything is clear now. You will be able to solve whatever question is there in the assignment also.
Yes, yes. I have
Yeah,
solved it actually. Like answer was wrong just now.
yeah. So anyway, I mean, did you understand everything here?
Yes, yes. I have understood.
Good. So I hope everyone understood everything
Like
here.
there is one thing like to go to the diagram, small signal equal. So here,
This one, right?
yes, here the current is zero, right? That's why the current source is zero. That's why it is open. But whereas this resistance is high, right? So that's why like small amount of current only flows. Like no current flows. That's why you have open circuited.
Yeah. So current source, if it is, if through a current source, no current is flowing. This I is equal to 0, which means what? Which means
Open
what?
circuit.
Which means that between these two terminals there is nothing, right? Nothing, no connection
Open
here.
circuit.
Open circuit, correct?
Yes.
Right. Now similarly, if you have a resistor, but it turns out that its resistance is infinity. What does this mean?
Like no current flows through it
Which
actually.
means that
And
if, it doesn't matter how much voltage you apply here, current through this will be always zero, right?
yeah. Yes.
Correct. So it is also effectively an open circuit, right? Infinite resistance is effectively an open circuit. Got it?
Yes. Yes.
Yeah. Shorts. Similarly, if you want to say that there is a short circuit, short circuit means you can say that this R is equal to 0, which means that it's a short circuit. Okay, there is no resistance. There is zero resistance between these two terminals, which means that it's a short circuit. Got it? So if somewhere you find R is equal to 0, which means that it's simple short. There is no connection. I mean, there is no nothing in between. There is just a plain wire. You can say like that.
Yes.
Got it? Huh. Similarly, if you have a voltage source like this between two terminals, and you find out that this voltage difference is 0, then also you can say that it is effectively a short.
Short circuit.
Yeah, it is effectively a short circuit. Yeah, fine. So understood, right? Everything.
Yes.
Yeah. So this was the one question that I wanted to discuss today. Fine. In week 2, I think I had something which I wanted to discuss. Yeah, did you find out? No, no, no. What did I do? Yeah. Did you try to solve this question? Did you try to solve this last part here? This was a homework which I gave you. Did you solve this? Okay, if you didn't solve this, I'm not going to solve it because you're not going to appreciate in that case. I wanted you to solve this because then you will be seeing. See the catch here is that I'll just give you a hint. You please try it again. Okay, please go home and then try it again once more today. You'll appreciate the problem here. You see, we do this analysis, right? We find out an incremental point and then we. I'm sorry. We find out an a quiescent point here, and then we applied an incremental voltage and saw how much is the gain and everything, right? Everything we saw after applying an incremental voltage around a quiescent point. We did that analysis. But the catch is that the incremental voltage or incremental quantity that you are incremental disturbance that you apply around the quiescent point should be very small. Okay, should be very small compared to the overall quiescent point. The quiescent point voltage should be much larger compared to the small disturbance that you apply. Only then can you use this analysis, incremental analysis. Here the problem is that here what was going to happen is because of the 6 milliamperes thing, the incremental current is so high that your quiescent point will be completely disturbed. You see, your quiescent current is how much? 6.5 milliamperes. If you apply over this quiescent current, if you apply large current, yeah, over this quiescent point, over this quiescent point of 6.5 milliamperes, if you apply a large current of 6 milliamperes, you can see that the whole operating point will go completely like this, right? It will not remain in the vicinity of this guy. It will move in a large area like this. It will move in a large this thing. It will move in a large area. So the incremental analysis will be completely disrupted. What I wanted you to do is that you assume that the incremental analysis still holds, okay, and you solve for the net current through the element E. Okay, that is what is 4, right? Solve 4 if I is equal to 0. So assume that the incremental analysis still holds, and using this small signal value of current, find out how much is the incremental total current that is flowing in that flowing through E, this terminal E. After that, when you find out the total current through E, you find out the two extremes of the current. So since it's a sinusoidal current, right? It will have a maxima and a minima. Sinusoid moves like this, right? So there will be a maxima and there will be a minima. So in these two extreme of current, you will see that one falls in this region and one falls in this region. Will not be so that basically violates the assumption that your incremental analysis holds. So please try it again today. Fine. Okay, so I only had one question to discuss in this week because there was nothing much here. This was the only thing I wanted to discuss. If you have anything else, you can ask me now. If you have anything else, you can ask me now. All right. If you have nothing else, then probably I will just end the meeting. We'll meet again on Tuesday. Okay.
Mayank, I
Yeah.
have raised a question one more like regarding week 4. Shall I ask it now only?
Week 4 I will
In
discuss
the
on Tuesday. Okay.
okay,
Okay.
like
I'll
in
be
video there is like I felt like there is like minus or plus there is some problem that you
okay.
have
I'll
mentioned.
discuss this on Tuesday. Okay. Please remind me again once again on Tuesday.
Yes, sure.
I'll discuss it on Tuesday.
Okay.
Okay. Thank you.
Like will that key be changed if possible?
I'll ask. I'll see what I can do. Okay.
Okay. Thank you, man. Thank you.
Yeah. Thank you. All right. So we'll meet again on Tuesday. Thank you very much for joining. Hope to see you on Tuesday.